So how many dependencies are there in your software? How do you identify dependencies using tools? And how do you generate attribution notices, especially if you are distributing your software? Uh, Types of software licenses. So I think here in this conference, pretty much everyone, I assume, knows the open source part of it. Like you have your 4 freedoms and source code is accessible and you can use it for whatever purpose you want. But on the other side, uh, as a user, many times you are also able to download lots of commercial software. There are pure commercial software such as Office, then there is CUDA, and you might find some software with EULA in it. On the other side, you might find yourself, if your vendor is supplying you some hardware drivers or some other code that may be coming with a condition that yes, it is, you are free to use it as long as you are using their own hardware. There might be some source available projects, or there might be some business source license where your vendor might tell you that yes, you can use this software as long as you are not competing with my core business. Then there are freeware, shareware, which are sort of not open source. And then on GitHub, as you will find lots of code that is just out there without any license. Uh, that depends if you consider that. Can you consider that as open source? The chance would be probably not. Now, as you use the software, your software will have some direct dependencies that you as a developer generally select or have control over it. But in many cases, the software, the dependency that you have selected have their own dependencies. And those dependencies may have their own dependencies, which are indirect dependencies. So you have your direct dependencies and then indirect dependencies, and the tree goes on for quite a while. Now, how does this impact you as a developer? So you as a developer should know what you are using and what you are providing to your users, customers. Some cases, your software may not require many of these dependencies, but they may be present. And license of all those dependencies may impact your use of the software, or may have even larger impact on your distribution of your software. Say if you are using a software, if you are downloading a software that is under fairly permissive license, and then you find out that one of the dependencies is, say, under a very restrictive license, your company's policy may prevent you from using those. Or if one of the dependency requires you to have commercial license, then at that point you might need to check with your legal department to make sure that you have commercial agreement to use that particular license. Security vulnerabilities in those dependencies that you are downloading or using may impact how you are using your software as well. Now, these dependencies are not set in stone either. They are dynamic, and risk associated with their use changes constantly. Dependencies aren't resolved in isolation. They are heavily dependent on the system. What time are you building your system? Dependencies also change over time, and they will change according to your system architecture. If you are using, say, Windows or Mac system for your build, during your run build, but if your system is running on a Linux machine, then your dependency tree might look completely different. Also, if you are not pinning your dependencies, then your dependency manager is going to decide which dependency version you are going to use. Some of them, say Maven, Go, NuGet, may end up using the older or stable version. Whereas if you are going with npm cargo or pip, you are going with the latest version, and the latest version may change with every whenever there is a newer dependency, and whatever that dependency management may have decided on their end. Dependencies come in different form. You specify what dependency you are going to use with lots of different characters. Every package manager or dependency manager may have their own dependency characters. So here is an example for Boto 3. Between two versions of Boto 3, you can see that between version 1.35 and version 1.37, the S3 transfer agent changed from 10.4 to 11.2. Other dependencies did not change, but the S3 transfer changed. Now, if you're, so for example, if you, for some other package, you might be having some sort of similar situation. I took the dependency from deps.dev. Google manages that project, I believe. Now, how does this impact you as a developer? Sometimes license of this indirect dependencies can have impact on license of direct dependencies that you are using, and that may affect, that may end up having some effect on your project. Right? This indirect dependencies are generally your developer, or you may not be aware of what indirect dependencies you are pulling in your project. So if you are generating an SBOM, you might just think, hey, I'm using just 5 direct dependencies, and that might be my SBOM. But when you are building and deploying your software, you might be pulling in a lot more. That can come as a surprise. They add a lot more complexity to your SBOM. Where now your SBOM will also get impacted by whether you are using this package as an internal, it's an external package, is the dependency that you are using is direct, indirect, right? What time are you using? If you build your software say 3 months ago, you created your SBOM 3 months ago, when say one of your dependency was at 1.5, but when you build it today, one of your dependency might be at 1.7, and they may have, or maybe 2.0, and they may have changed their dependency tree. Then the SBOM that you created say 3 months ago may not be correct anymore. It will also depend on your environment, which operating system you are running on, or which hardware platform you are running on. Also, sometimes your CI/CD tools might inject some dependencies. Many people use, say for example, Chromium as a build system. It's not using your build. You might be using sometimes build from an external system. So that might inject some more dependencies that you may not be aware of, or you may not be actively planning on. They might be injecting dependencies that you may not be planning to include. Now, how do you limit the impact of all this uncertainty? You need to make sure that you are conducting audit of your dependencies. Ideally, you should be using some sort of tools that will be like say npm check, or Maven or Gradle dependency plugins, depending on the language you are using. You should also use package managers log file, so at least you are pinning your dependencies and using. So if dependency version of your dependency changes, that does not throw your dependency tree completely off. And if you are removing dependencies that you think are not probably useful, or the version change and you are not comfortable with it, make sure to test your project so that one of the dependencies don't break your system. This is the part where this is the report from Sonatype, and developers normally underestimate how many dependencies or how many packages that they are using. Like about quarter of the packages have about up to 25 packages per app. But on the other side of it, for many extra large packages, you are using over 400 packages per app. We'll see sometimes Docker containers that have over 10,000 packages in them. And like if you are, when you are pulling your Docker image may have just you might be just pulling say, hey, Ubuntu or Amazon Linux Docker base image, and then you are installing maybe 20 packages, but those 20 packages may bring like up to the 6th or 7th order dependency, and then you have a large package size and large SBOM. This one is also from Sonatype, which basically says like how many dependencies you get for average package. And if you are using say npm, your average dependency count is fairly huge. Now, does your project need all those dependencies? Depends on your project, but chances are when you are building your system and deploying it, you are using many of those, and not all those dependency your developers may know first order dependencies, but may not know all those second order. Now, this is the part where I want to very I want to emphasize about this disclaimer. My presentation is not an advice on how to generate attribution notices. I'm just sharing best practices. Before you take any action, you should talk with your company's legal advisor, or if your open source program office, if you have one, before you start acting on any of this, any of the demo tools that I show. For this particular presentation, I used Amazon Linux machine for my demo. So some of the commands that you see are very particular for Amazon Linux, Amazon Linux 2. It might be different for your system. With that disclaimer, I'll move to the next part. Now, you can do, there are different ways of identifying dependencies. The easiest way would be when you are downloading, say, a project from GitHub, or you have pulled it from one of the, say, PyPy or NPM or whatever language you are using, and you have the project. You can look into its requirements file, or TOML file, sometimes TOML file, or package.json, and you can see, as a developer, you can see what dependencies the project that you are using has declared, and how many of those you think you might be using, or what you are now getting yourself into. However, this manual process gets cumbersome very quickly, so people should use package managers to reduce the manual work. OSS package managers will generate some sort of SBOM, and generally they will allow you to use common SBOM formats such as CycloneDX or SPDX. They will rely on package manager metadata. They will help you generate package inventory. Generally, generally all the packages in the same package ecosystem that you are using, you are installing using the package manager. And because this package manager has all the information that is easily disseminated, that it was able to acquire, assuming that the original developer who created this metadata to an extent and identified them correctly, it will, based on that information, it can create an attribution document for you. A few examples of these package managers for native languages, like pip for Python. Then you have npm, Maven, Go license for Go. Then you have Sift, that is for Docker images, and sometimes say for Docker images, Sift will also use many of this same native package managers as part of its as part of its data collection. Another one is Trivi that I did not mention here. That is also pulling, that runs say other package managers underneath as well. But sometimes they work, so especially like say for Go license, for Go, you have to run Go license inside your Docker image to get the proper metadata. Otherwise, your Go packages might just get listed, but you don't have its license information. So you want, as a developer, you want to also check your SBOM or the attribution notices that you are getting generated. You should review it for completeness. No tool is perfect. All tools have their own limitations, and as a developer, you should know what tool you are using. Here's an example of how I generated attribution for Python packages. So for Python, I installed CycloneDX BOM and pip licenses, and I generally like to see things in an Excel format. I use Excel on my computer, so I like to get output in CSV format that I can filter out with Excel. So with pip, when I install pip, so you can see the dependency graph of CycloneDX here. It's fairly large. It does pull in some packages that you don't expect. It takes some trial and error to understand that, hey, sometimes when you're running pip license, it's also scanning what you have installed to generate the SBOM. And that comes out as a surprise. We also install pip license and the CSV kit on Amazon Linux 2. Once they are all installed, you run pip license. It will basically provide you it will provide you information about what packages you have and what licenses they are pulling, what licenses there are. And as I mentioned, I like to see Excel output. So I generate things in an Excel. Because I was running Amazon Linux instance, I just use a very small snapshot of this Excel file or CSV file. There you can see all the licenses in one of the columns. It makes it easy. If you are familiar with Excel, you can filter out lots of this output, and you can focus on packages that you are interested in or licenses that you are curious about. That's for the Python. This somewhat similar action I also did for NPM. There also I used the NPM Cyclone DX package, and for that I had to install NPM and which NPM license I was a license checker, and then again CSV output for that. Here in the Linux system, when I was trying to get NPM, I installed CSV kit with pip3. And when I see these packages now, because I'm running NPM as a license checker, it may not necessarily capture the CSV kit that's on the system, because the package manager is limited to the system that it is controlling. So if you are using multiple package managers to install items on your system, you might want to use more than one package manager to know what your final output is. Similar things for MVN package. Here, for example, I'd use common lang 3. I'm not as familiar in the Maven ecosystem, so I had to, one of my PE wrote a particular script. One of my engineer, one of the person on my team wrote a script that I copied in its pom.xml, and then I built the pom package, and it created BOM.xml for this particular package. Once I had BOM, I had to go and convert that BOM into legal notices. So I had to use another set of commands, and so I had to use another repo, that is this GitHub repo for OSS attribution sample apps, and using that, I was able to convert the notices from BOM.xml into a legal notices text that you can distribute with your project. If you are using it for internally, then BOM.xml is sufficient enough for you. But as many of you know, for open source projects, distribution is the key. When you change from internal use to distribution, that's when your compliance obligations go up, take a step up. Now I also use Go packages to install to generate attribution for Go. Here I use the Air project from Go, one of more popular Go projects, and you can see that it has a fairly complex dependency graph. On Amazon Linux, it was a little bit tricky for me to install Go. I'm not a software engineer, so I used AI tool to learn all these languages. I did some iterative works to make sure that I was able to install all these package managers. So first I had to install Go on my system. Once I had Go running, I was able to install. I installed Go licenses, and again CSV kit to generate my clean output, and Air package. Once I had those installed, I was able to generate a license.csv file here as well that allowed me to see. Now, funny thing about Go is that if you are, say, running it inside, say, some container, the container manager such as Sift may not be able to pull Go license information. So this is, I might have to repeat the same process inside a container to see how you can actually use that. The same, sure. It was one of the more popular Go packages. I did not know what it. That was just an example. Yeah. I was trying to figure out what package I can use, and because work in open source program office, so I went and check, hey, what is the more popular package in each? So for Golang, so for this one it was Air, for Maven it was Commons Lang 3. I was able to crack, so I was like, and it also depends what I can install on my system. That is all. So with given my technical ability, what I can install. So I try to keep it simple. I'm sure there are a lot more complex projects that people can try, but for me, that for the basic demonstration, this worked out. Yep. Uh, One of the sorry, I went back. Okay, so for cargo, the package that for example package I used was Foundry, and you can see it has fairly complex again dependency graph, and again, because my system was a clean Amazon Linux machine, I had to install Rust and Cargo on them, on that machine. And once I had installed that, I had to add this particular section here on shown on the right on in the about.toml. Once I had that, and I had cloned the Foundry, I was able to generate a license HTML file for it. In this particular case, I had to write another script to convert that HTML into an Excel so that I can see the file, I can see the license of packages fairly easily. But because I had TOML and I knew what packages the system was building, it was somewhat more acceptable, easier notices, but uh, sometimes the package managers don't necessarily give you output in an Excel output. That I prefer, but you might get a JSON output that you might be able to use as well. The next package manager I used was Gradle. Now for Gradle, I had to install in my system Java, Gradle, and Kotlin as well to run my demo project. So once I was able to install Gradle, uh, I built a simple demo Gradle app. And with that demo Gradle app, uh, because I am not a good programmer, I had to write down which options I selected for this basic app. And once I was able to create the app, I added a tiny script to my Gradle KTS. Believe that this is the part that I added. Uh, yes, this is the part that I added to my Gradle script, and that allowed me to build a bomb.xml for my demo project. And once I had my demo project, I again went to this OSS attribution sample repo on GitHub and used BOM to notices to convert this BOM into a legal notices file. Again, here, because the way I had installed packages on my system, my reports were in a completely different directory and compared to where I was copying my repo for creating SBOM. And once I had converted the notices, again here I was able to generate notices in a text file that I use a different script then to convert it into an Excel output. Right. Now, generating the attribution notices for Docker images, many of you might be using Docker containers or some other form of containers for your use. Here I'm showing how to use Sift. That's the open source tool that Anchor offers. Yes, here also use Cyclone DX. So Sift output is in JSON, and it's with Cyclone DX. It's in Cyclone DX format. I converted that into CSV as well, so I can work in Excel and see the output. Now, in my particular case, because I was running this in Amazon Linux 2 desktop, uh, I had to install Docker Compose, Sift, Java, Cyclone DX, and CS Wicket to see the output as well. Uh, I did not have a ready-made Docker file, so to test the project, to test if the Sift gives me a proper output, this was like one of the example Docker file we had created. It adds lot more. It adds a little bit more complexity to base image, and then basically I had to build a Docker image. Once I had Docker image built, uh, normally, because sometimes you might have multi-state Docker image, and if you're running on a live Docker image, you may not be able to get all the layers. You may not be able to get all the information. So so I would export it into a tar file so that all the information is sort of captured, and then I run Sift. I run Sift scan to get a JSON output, and once I have the JSON output, then I can convert that into an Excel that I can test, that I can see with Excel. Next is my conclusion for the talk. Now, software does come under lots of different licenses. We need to ensure that you as a developer need to ensure that you are complying with the terms. Software also comes with lots of direct and indirect dependencies. Is you want to make sure that you have identified correct dependencies that you are using. Also, dependencies change wherever, when, how you are using them, when how your software is being used. Uh, Again, with a disclaimer, you should use package managers to generate package inventory, and especially if you are distributing your software, you can use the same package managers to generate attribution notices.